Dear students, in this video we are going to discuss about oxidation number or oxidation state. Oxidation number or state. So what is oxidation number is nothing but the charge that is real or imaginary. The charge which an atom appears to have when it is in combination. So what is oxidation number is when atom is present in the combined state or combination with other atoms. So when atom is in the combination, the charge of that atom is called oxidation number. Okay. So the charge of an atom when it is in the combination is called oxidation number or oxidation state. So we can determine the oxidation numbers for ionic compounds and covalent compounds in this video. So now first of all we can see how can we determine the oxidation numbers for ionic compounds. So in the case of electrovalent compounds, that means electrovalent compounds are also known as ionic compounds, right? So in the case of electrovalent compounds or ionic compounds, the oxidation number of an element or radical is the same as the charge on the ion. So how much charge is present on that atom, that is the oxidation state in the case of ionic compounds. So this is the real charge and is developed by the loss and gain of electrons. Okay, so this is the real charge and this charge is developed by the loss of electrons or gain of electrons by that atoms or radicals. For example, sodium chloride NaCl. So the charge of or on sodium, no need this much. So the charge on sodium, the charge on sodium is +1 and chlorine is -1. Okay, so the charge on sodium is +1 and chlorine is -1. How can we say the charge of sodium is +1? Because sodium lost 1 electron to get the noble element configuration, neon, and chlorine is -1. It is getting 1 electron to get the electronic configuration of argon. Okay, so by the loss of 1 electron, sodium gets positive charge, 1 positive charge, and chlorine gets negative charge. So this charge have been developed by the transfer of 1 electron from sodium atom to chlorine atom. Okay, so due to the transfer of electrons, sodium gets 1 positive, chlorine gets 1 negative by the gaining of electron. So in NaCl, the oxidation number of sodium is +1 and chlorine is -1. So by this example, what we can understand is the charge of the atom present in ionic compound is equal to oxidation number or oxidation state. So this is in the ionic compounds. So this is for ionic compounds. So now we can discuss about covalent compounds. So how can we determine the oxidation number or oxidation state for covalent compounds? See, the oxidation number of atoms in covalent compounds can be derived by assigning the electron of each bond to the more electronegative atom of the bonded atoms. So how many electrons are assigning to the more electronegative atom in covalent compounds are known as oxidation state or oxidation number. So you can understand better with one example. So we can see hydrochloric acid, HCl. So HCl formed by the combination of hydrogen and chlorine by the sharing of 2 electrons. That 2 electrons are provided by the hydrogen and chlorine. Okay, so we can write like this: hydrogen, chlorine. So this line represents covalent bond formed by the sharing of 2 electrons. That 2 electrons are provided by 1 electron from hydrogen, 1 electron by the chlorine. Okay, so that 2 electrons I am representing with 2 dots. So that 2 dots I represented in between center of these 2 atoms. Now what happened? Chlorine is more electronegative. Chlorine is more electronegative than hydrogen. Okay, that's why these 2 electrons are pulled towards the chlorine. Pulled towards the chlorine because chlorine is more electronegative. That's why we are assigning that electrons to the chlorine. So I am writing like this: hydrogen and chlorine, chlorine containing neutral state. Sorry, in the neutral state containing chlorine 7 electrons. So that's 7 electrons. And now eighth one from the hydrogen. So now chlorine containing how many electrons? 8 electrons. Okay, so chlorine containing 8 electrons. So now we assign the electrons of the bond to more electronegative atom. Okay, how many electrons we assign in this case? 1 electron from the from hydrogen. 1 electron promoted, I mean 1 electron provided to the formation of covalent bond. So that 1 electron we assign to the chlorine. So in this case, now that's why this chlorine gets -1 charge and hydrogen gets +1 charge. So this is the oxidation number of chlorine and this is the oxidation number of hydrogen. So that only now we discussed before. So you see here, assigning the electrons of each bond to the more electronegative atom in a covalent compound is oxidation number or oxidation state. So in the hydrogen chloride, okay, so in the hydrochloric acid or hydrogen chloride, we assign 1 electron to chlorine in this bond. That's why it will get -1 and it will get positive charge +1. Okay, like this we can determine the oxidation number in the case of covalent compounds. Now one more covalent compound I am writing here, H2. Now how can you say H? So how many electrons are assigned to the more electronegative atom here? So here no more electronegative atom because both are hydrogens and both are having same electronegativity. That means electronegativity difference is 0. So no electronegativity difference in between these 2 hydrogens. That's why electronegativity difference is 0. So here no assignment. We are not assigning any electron to any hydrogen because no electronegativity difference. So that's why we can say oxidation number 0. For example, Cl2. So Cl2 also both are having same electronegativity. So here also not assigning electrons to more electronegative element or atom. So here oxidation number is 0.